There is a place on this earth where you can press your hand flat against a wall of exposed rock and touch something that was already old before the first tree ever grew. Before fish had learned to crawl onto land, before the oceans had settled into the shapes we now call familiar. The stone beneath your fingers was already there, already compressed and folded and worn, while most of what we consider ancient history was still billions of years away from happening. These are not merely old mountains. These are the elders of the planet itself, and understanding them requires us to completely dismantle the way we think about time. When most people hear the word ancient, their minds travel to Egypt, to Rome, to the crumbling temples of civilizations that rose and fell thousands of years ago. Perhaps the bolder imagination reaches back to the dinosaurs, those magnificent, terrifying creatures that dominated the Earth for over 165 million years before a rock from space ended their reign. But even that staggering number, 165 million years, is a mere flicker in the context of geological time. The mountains we are about to explore were already worn down and resurrected, already folded and refolded by continental collision, already carrying within their bones a history so deep that the dinosaurs themselves would have looked up at some of these peaks and seen something older than their own evolutionary lineage by a factor that defies easy comprehension. The Appalachian Mountains of eastern North America are perhaps the most quietly remarkable geological feature on the surface of this planet. They do not look the part. Driving through Virginia or Tennessee or Pennsylvania, you see rolling green hills, softened ridgelines, forested slopes that seem almost gentle compared to the savage verticality of the Rockies or the Himalayas. Tourists pass through them without ceremony. Hikers walk their trails without fully grasping that they are moving across the ruins of something that was once arguably the tallest mountain range in the history of the world. Because that is what the Appalachians are. Ruins, the skeleton of a colossus. And that skeleton is, in places, nearly 500 million years old, with roots of metamorphic rock that push even further back, past 1 billion years, into a time so remote that the very oxygen content of the atmosphere was still being negotiated by single-celled organisms. To understand how a mountain range can be this old, you have to understand the engine that builds and destroys mountains in the first place. The surface of the Earth is not a single solid shell. It is broken into enormous interlocking plates of rock, the tectonic plates, that float on a layer of semi-molten mantle material below, driven by the heat of the planet's core. These plates move slowly, on the order of centimeters per year, roughly the speed at which your fingernails grow. But given enough time, even fingernail speed movement reshapes entire worlds. When two continental plates collide, neither can simply slide beneath the other the way oceanic crust can. Instead, they crumple, buckle, and heave upward, piling rock upon rock in enormous crustal thicknesses that eventually erupt skyward as mountain ranges. This is how the Himalayas are being built right now, as India continues to drive northward into Eurasia. This is how the Alps rose. And this is how the Appalachians were born. Not once, but at least 3 distinct times across hundreds of millions of years of repeated continental collision. The first great building event that contributed to the Appalachians began roughly 480 million years ago, during a period geologists call the Ordovician. At this point in Earth's history, the landmasses we know today did not exist in anything like their current form. North America, then called Laurentia by geologists, sat near the equator, largely flooded by shallow tropical seas. There were no forests, no land animals, no insects, no amphibians. The most complex life on Earth consisted of marine invertebrates, trilobites scuttling across seafloors, cephalopods drifting through warm water, corals building the first great reefs. Into this world, an ancient volcanic island arc, a chain of islands not unlike modern Japan, came grinding into the eastern edge of Laurentia. The collision crumpled the crust, thrust enormous sheets of rock westward over hundreds of miles, and pushed up a mountain range geologists call the Taconic Mountains. These mountains were enormous. They shed so much sediment westward that the debris filled in vast portions of what is now the American Midwest, creating rock layers that geologists can still read today like the pages of a book. The tectonics eroded, the sea returned. And then, roughly 375 million years ago, during the Devonian period, it happened again. The second great collision, called the Akkadian orogeny, was even more violent. By this point, a small continent called Avalonia, carrying fragments of what would become parts of New England and maritime Canada, came sweeping in from the east and drove into Laurentia with tremendous force. The resulting mountains were staggering in scale. Geologists estimate that at their peak, the Acadian Mountains may have reached elevations comparable to the modern Himalayas, peaks perhaps 5 or 6 miles high, stretching in an unbroken chain for thousands of miles. The Devonian world was beginning to green. The first forests were appearing, strange and alien by modern standards, dominated by enormous tree-like plants called Archaeopteris and towering lycopsids. Fish were diversifying explosively in the seas. And over all of this hung these incomprehensible mountains, shedding rivers of sediment westward that buried ancient seabeds under thousands of feet of rock. Rock that today forms the coal-bearing strata of Pennsylvania and West Virginia. Rock that powered the Industrial Revolution. Rock whose origin stretches back to mountains that existed before the first amphibian ever pulled itself from a river onto dry ground. The third and final great collision came later still, during the Permian period, roughly 300 million years ago, when all the world's continents ground together into the supercontinent Pangaea. This event, the Alleghanian orogeny, was the culmination of a planetary-scale collision between Laurentia and the combined landmass of Europe and Africa, then fused into a single continent called Gondwana. The impact was apocalyptic in geological terms. It pushed enormous thrust sheets of rock hundreds of miles inland, folded and refolded the existing mountain structures, and built what may have been the grandest mountain range in the history of the planet. These were the ultimate Appalachians, Himalayan in scale, perhaps greater, a wall of stone running from what is now Alabama all the way to Scandinavia and Morocco. Because in Pangaea, all of those places were joined. When you stand in the Atlas Mountains of Morocco today and look at their folded rock layers, you are looking at the same mountains, literally the same continuous range, as the Appalachians of North Carolina. They were torn apart when Pangaea rifted open and the Atlantic Ocean was born, roughly 200 million years ago. The dinosaurs were just beginning their long reign when that rift opened. The mountains it separated were already ancient. And then came the erosion. This is perhaps the most astonishing chapter in the Appalachian story, and the one least appreciated by anyone who passes through them without geological eyes. From their Permian maximum height of perhaps 5 or 6 miles, the Appalachians have been slowly, relentlessly ground down by water, ice, wind, and the patient chemistry of weathering for 300 million years. Every raindrop that strikes a mountainside carries away atoms of rock in solution. Every freezing cycle wedges ice into cracks and shatters stone. Every river carries the mountain, grain by grain, toward the sea. The material that was once these towering peaks now lies buried beneath the coastal plains of the eastern United States, beneath the sediments of the Atlantic continental shelf, scattered across the ocean floor in a vast apron of ancient mountain debris that stretches hundreds of miles from shore. The mountains gave themselves to the sea. What remains is their deepest root, the metamorphic and igneous core that was once buried miles beneath the surface, now exposed by eons of erosion like the skeleton of a great animal whose flesh has been stripped away by time. But the Appalachians are not even the oldest mountains in the world. They are merely the most instructive example in North America. To find the true elders, you have to travel further, to the cratons, the ancient cores of continents that have survived essentially unchanged since the earliest chapters of Earth's history. In Canada, the Canadian Shield exposes rocks that are among the oldest on Earth's surface, some of them pushing past 4 billion years in age. The Acasta gneisses of the Northwest Territories, dated at approximately 4.03 billion years old, are the oldest known intact crustal rocks on the planet. They formed when the Earth itself was barely 500 million years old, when the planet's surface was still being hammered by the tail end of the great meteorite bombardment that scarred the early solar system, when there was no life, no oxygen atmosphere, nothing but volcanic rock and poisoned oceans under a young, dimmer sun. The Barberton Greenstone Belt of South Africa carries rocks 3.5 billion years old that contain chemical traces of the earliest life, microbial mats, stromatolites, the faint biochemical fingerprints of organisms so simple they had not yet invented the cell nucleus. The Pilbara region of Western Australia hosts similarly ancient rocks, and walking across them is not a metaphor for time travel. It is as close to actual time travel as a physical human body can achieve. You stand on rock that existed before the moon's cratering had finished, before the continents had taken shape, before evolution had yet discovered the trick of the eukaryotic cell that would eventually give rise to every complex organism that has ever lived. What does it mean to be this old? What does it mean for a piece of stone to have survived 4 billion years on the surface of a planet that has been tectonically churning, meteorite battered, ocean flooded, ice scoured, and biologically transformed for its entire existence? It means surviving the Snowball Earth episodes, when glaciers may have covered the entire planet from pole to equator. It means surviving the Great Oxidation Event, when photosynthesizing microbes began flooding the atmosphere with oxygen, a gas that was, at the time, a toxic pollutant that poisoned most existing life and completely restructured the planet's chemistry. It means surviving the assembly and breakup of not one but multiple supercontinents: Kennerland, Columbia, Rodinia, Gondwana, Pangaea, each one a planetary reshuffling that ground continents together and tore them apart over timescales of hundreds of millions of years. The rocks that carry this history are not passive objects. They are the only witnesses to events that no other evidence on Earth has survived to record. There is a concept in geology called deep time, and it was one of the genuinely revolutionary ideas in the history of human thought. When the Scottish geologist James Hutton first articulated it in the late 18th century, arguing, from his reading of rock layers and erosional processes, that the Earth must be incomprehensibly old, it was deeply unsettling to people who had assumed the planet was only a few thousand years old. Hutton looked at the angular unconformities in the rocks at Sicker Point on the Scottish coast, places where ancient tilted rock layers were buried, compressed into mountains, eroded flat, and then buried again under new horizontal layers, and understood that this cycle must have required not thousands, but millions of years to complete. Standing at that outcrop in 1788, looking at evidence of multiple mountain ranges rising and eroding away beneath his feet, he reportedly said that he could find no vestige of a beginning, no prospect of an end. He was overwhelmed not with certainty, but with vertigo. The same vertigo still grips anyone who truly grasps what they are looking at when they look at old rock. Because the deepest challenge of these ancient mountains is not scientific, it is psychological. The human brain did not evolve to handle deep time. We are animals built for the time scale of a human life. Perhaps the time scale of a few generations of remembered ancestors. Perhaps at a stretch, the few thousand years of recorded history that we carry in our cultural memory. The 65 million years since the dinosaurs vanished is already essentially incomprehensible, a number we can say but not feel. The 300 million years since the final Appalachian collision is 5 times beyond that. The 4 billion years since the Acasta Nices crystallized from molten rock is 60 times beyond that. There is no emotion in the human repertoire equipped to receive information on this scale. We can do the arithmetic, we cannot do the feeling. And yet something happens when you stand at a road cut on a mountain highway and truly look at the exposed rock face rather than past it. You begin to see the layers not as scenery, but as sentences in a narrative. That band of quartzite, once a beach, compressed into stone. That dark intrusion of basalt cutting diagonally through older rock, a crack that opened in the crust, filled with magma, cooled, was then buried and unburied over hundreds of millions of years. That fold in the limestone, a gentle S-curve in rock that was once as fluid as bread dough under the pressure and heat of mountain building. Evidence of forces so enormous they made solid rock flow like putty over timescales of millions of years. Every exposed cliff face is a library. Every road cut is an archive. And the books they contain describe a world so alien to our daily experience that reading them properly is an act of genuine imagination. The same kind of imaginative leap required to understand that the light arriving at your eye from a distant star left its source before the Earth existed. The mountains that were already ancient when the dinosaurs ruled Earth are still here. They are quieter now, worn down, forested, crossed by highways and hiking trails, and the casual indifference of a species too young and too busy to fully notice what it is walking across. But they endure. They will endure long after everything that currently seems permanent and important has dissolved back into the geological record. The forces that built them are still at work. Plates still moving, magma still rising, rain still carrying mountains grain by grain to the sea. In another 100 million years, the Atlantic will have closed somewhat, and new collisions will be underway. New mountains will rise on the bones of old ones. And whatever is alive in that future world, if anything reads the rock at all, will find layers that contain the thin, strange signature of us. A brief chemical anomaly, an unusual abundance of certain isotopes, the microscopic remnants of materials that never existed before one particular species spent a few centuries burning ancient carbon and scattering synthetic molecules across the surface of a very old planet. We are, in geological terms, the blink of an eye. But the mountains were here before the blink, and they will be here after. They do not require our recognition to be magnificent. They have never required an audience. They were ancient before there were eyes to see them, and they will be ancient still when the last eye closes. What we can do, the only thing we can do, is look at them long enough and hard enough and honestly enough to feel, even briefly, the full weight of what they are. Not scenery, not backdrop, not resources waiting to be extracted or trails waiting to be hiked. Witnesses. The oldest witnesses on Earth, carrying in their layered, compressed, folded, metamorphosed bones the entire biography of a living planet. A story so long that every chapter we think of as history is nothing more than the final punctuation mark on a sentence that began before the sun had finished forming, in a solar system that was itself born from the scattered ashes of stars that lived and died before our own star ever ignited. Press your hand against old rock. What you are touching is not the past. You are touching the record of time itself, and it goes back further than you can possibly imagine.